Hi guys, today we have logical equivalents. Okay, the two compound propositions are said to be logical equivalents if and only if they have the same truth values. This means that the truth table, that's the last column of their truth table, must be the same. The last column of their truth table must be the same. We say that both propositions have they are logically what? Equivalent. Okay, let's dive into it. Okay, let's see this example. Of course, we have only P and Q coming out in the question. We have only P and Q in the question, so we have the table to contain P and Q alone. Of course, P will truth, false, we have there. Truth, false for Q. Then the first thing I am going to talk about now is the one having negation, is what I'm going to write now. So I'm going to have P and Q. The first thing is the one inside the bracket having the one that contains negation. Always try to deal with the ones containing negation first if you want to get your answers accurately without any error. Tackle the ones having negations first. So I bring in the one that has negation just as I did before. I come in here. So under P and Q is conjunction. We maintain only the place we have truth is going to be truth as far as and a conjunction is concerned. Then others are false. Okay? Now, after that, I will get to my, okay, let's have my, of course, I need to get this side before I can now compare the whole thing. So I need to get my P or Q. Okay? Okay? And get my P or Q. Then I can now get my negation P and Q. Okay? Right? Now, having gotten this P and or Q, and I of course I negate this one, negation P and Q, I can now write this very one because I can combine this so that it will appear at the last column. You know? So here is P exclusive disjunction Q. Then I will now combine everything here to be P or Q and negation P and Q. Okay? You see the two things we are comparing appearing at the last column. So we can be looking at both of them to know whether they contain the same truth value before we say or we conclude that they are logically equivalent. Okay? So now P or Q on this P and this Q under or disjunction, we take only FF to give us F. It takes only FF to provide F. Then others, once you can see truth at all, you're going to what? There is a truth here. Everything is going to be truth. We have truth, and truth. Under disjunction is only FF that can produce F. Then once there is existence of T, definitely P or Q has to be T. Okay, the negation of P and Q. This is already P and Q, that's why we got it before now. Then the negation means changing everything here to the opposite. The negation of truth is false. Negation of false is truth. And we have another false, and we have another false, we negate the whole thing. Okay? P, exclusive disjunction Q. Under exclusive disjunction, it means P or Q, but not both. Meaning, if both are truth, it will be false. P or Q, but not both. There is P or Q. This is P or Q, but not what? This P or Q, but not both. Then both are truth here. Both cannot be true, but either P can be truth or that Q can be truth, but both cannot be truth. So this exclusive disjunction means it carries all the properties of all, meaning F or F is still F. False or truth is still truth. Then truth or false is still truth, but truth or truth. Under normal or, it is truth. But under exclusive or, it is an exclusive disjunction or exclusive or. So under exclusive disjunction, truth or truth has to be false, because the meaning of this exclusive disjunction is either P or Q, but not both. It means P can be truth or Q can be truth, but both cannot be what? Truth. So it is false when both are truth under exclusive disjunction. So both are truth here. Under exclusive disjunction we have false. The normal or, truth or false, that one still holds truth. False or true, that one holds still truth. Then false or false is still false. If you watch, you find out that on comparing with or, 1, 2, 3, they are just the same. Because of the exclusive, this one that is T is now what? F, because both can't be truth. That is the meaning of P or Q, but not both. Meaning when both is truth, it becomes false. P can be truth or Q can be truth, but both can be truth. Okay. The last column is now saying P or Q, which is this guy here, P or Q, and negation P and Q. Okay? So we're going to use and to combine these two guys now. So and says truth to give you truth. As you can see, this is truth and truth under and conjunction. They must have the same truth. They must have the same, both of them must be truth. Okay? For P and Q to be truth. So under and, both must be truth. So we have truth here. Of course, this one is truth false. We have to have false. We start with false, truth under and. We have truth, we have truth, and false to false. Okay, truth, and then false to truth is what? False. So what are we trying to say? We are trying to say that you can under and you can use common reasoning, like 1 times 1 is 1, 0 times 1 is 0, 1 times 0 is 0, and 0 times 0 is 0. So use that logical ability to be able to deal with conjunction. Whenever you do with conjunction, truth and truth is truth, but any other one definitely will give you false. Okay, so we can see we have this guy and we have this guy. The last two columns, this guy here produces FTTF. Then this guy here produces FTTF. Therefore, it is true that P exclusive disjunction Q is logically equivalent to P or Q and negation of P and Q. We have our answer.